Okay, the next step is to go and create standard deviation rasters. So we can look at injecting noise into our covariates based on standard deviation of a downsampled raster. Here we've got a function that I've created, and I'll go ahead and paste that into R. And if we take a look at the function, you'll see that first I define a number of different options for what you want out of the downsample. So this function will downsample a raster. You give it the original raster, the cell size that you want, or really the downsample rate, how much you want to downsample, and then the type. And so the type is one of these. Now, I think you can get all of these except standard deviation out of QGIS or ArcGIS. So that's probably where you'll use it. And I'm just going to go ahead and run that function. Whoops. Make sure I run the whole thing. Boom. And now it's over there, so I can use it, as are my constants. And now I can go back to the website. And this next set of code is going to call that, create a standard deviation raster. I'm going to go ahead and put some hash marks in here to separate out the function from the rest of it. And I do need to load some additional libraries here, the Raster, Spatial library, and GDAL. This one gives us the raster structure, spatial operations, and then GDAL is the library to read and write rasters. Now this is a little bit different because I have a folder path going to a folder on disk, and this has my input file in it, and we'll also put our outputs in there in a bit. So then what we do is we paste those together, okay, using this function, and I'll show you how that works. So paste takes the input file name and it's going to paste it to the end of the folder path so we get an input file path. Now, you have to add this little separation equals a blank string, sorry, or an empty string. Notice there's nothing in that string. Okay, otherwise it'll add a space. Kind of annoying, but it works. Then we can go ahead and load our raster. Notice it's a raster layer that we can't really look at, and eek. It's okay, it's there, it works. Then we set the cell size. So in this case, I'm going to downsample by a factor of 2 in each direction. And then we do the downsample. This will take a while. This is a raster for California. I think it's 1 kilometer, so it's fairly large. Larger ones, of course, will just take longer. And then it should come back with our new raster. So this is one that's been downsampled. In this case, it has standard deviation of the downsampled pixels instead of a mean value. And now here again, I'm using paste to take the folder path and create a file name that has new raster, the cell size, TIFF, and again our separation to make sure it doesn't stick blanks in there. And now we should have a nice output path that puts it back in the same folder. And then we can go ahead and write out our file so that we can use it again later. And then just to show what's in the raster, I am going to go ahead and grab a matrix. So this is how you can look at the actual values within the raster. Now notice they're all NAs. Well, that's because this is California, so a big portion of it is no data values, and those appear as NAs inside the matrix. Now again, it's hard to look at large data sets like this, but we can still do operations on them, and we do need to add this na.remove equals true. Okay, that way when we call any of the functions inside of R and we pass it a matrix that has NAs, it will ignore those. Otherwise you'll get NA as the result. So here we can see our overall mean of the standard deviation of the downsampled pixels. Hope that's cool. And now we can bring that standard deviation raster back into our GIS package and extract those standard deviation pixel values either for a set of sample locations or for an entire study area.